Good morning, everyone, and a very warm welcome for today's webinar. The topic is seismic design and safety for structures and connections. And we have with us two eminent speakers. First speaker will be from Bureau of Indian Standards, and second speaker is with us from Global. But before that, I will take some time, take some minutes so that we can have more participations, and then we will start the main session. So this is the second quarterly webinar organized by Seismic Academy, and a little bit talking about why we always choose seismic topics through this academy, because we are also aligned with the industry thinking and the government like BIS thinking, and earthquake is a very important topic, and the awareness is being driven all over the India in a very meaningful way. And also, if we talk about past earthquakes, we see that there are a lot of devastating consequences. Even this week also, if we see the record, on 15th May, there was an earthquake of magnitude of 6.7 in Japan. So there was no major failure, but earthquake is happening every now and then somewhere in the world, maybe not in India, but in other part of the world. So we cannot avoid it, but we can make the design in such a way to make the built environment resilient and seismic safe. So with this, I would like to take some minutes to talk about what Seismic Academy, the objectives. So we are always with the aim towards making construction better. And this forum is actually as an initiative by Hilti India. We talk it as a knowledge exchanging forum for professionals, for academicians, and for industry. But my screen is visible. Can Baz or Jitendra sir confirm?
Yeah, screen is visible, but I think it is on video.
We can see a black screen, Agamoni.
Okay.
It is a black screen basically. Yeah.
Okay.
Screen sharing is on, but it is a black screen is coming.
Agamoni, I would request you to please reshare the screen once through the Microsoft Edge tab.
Yeah, I just do it. Is it visible now? So
no,
I just.
I think you have to reshare the screen. It's not yet visible. Yeah.
Okay, just give me some moment.
Sure.
Just reshare. Is it coming now?
It's coming now, yes. Very good. We can
Yes,
see.
yes, perfect.
Okay. Yeah. So actually, this academy was launched, started in 2019, and we have a very strong advisory board with us from academia, from industry, and also we engage them through different activities. You see in the screen that there are some quarterly and trimester activities we do, like quarterly webinars, the second one for which we are here today. We do a lot of workshops frequently with IITs, with different associations. We release trimester publications also on seismic topics, and also to exchange the knowledges and to gain the expertise also, and also to elevate it further. We also try to be involved in all the national level conferences, which is organized by major associations in India. We present technical papers over there, and also we are involved with some IITs through research and testing based on the requirement and the industry objectives. Also, we conduct annual conference every year. The date is generally in October. So we have a dedicated website also where we publish all this kind of informations on earthquake related topics. This year also we started one online event, which is quiz competition. and we got good participation there. So the quiz competition was on the topic of earthquake safety and strengthening of structures. So we also had the privilege of hosting leading experts in earthquake engineering from academia as well as from industry. So these are some topics which is actually very much related to earthquake design and safety of structure has already been taken care of through webinars and also through journals. Also, we have a close collaboration with NIDA, BIS, BMTPC, DDMA. Also, we are associated with Indian Buildings Congress, Indian Association of Structural Engineers, ISC, IIT, ICSRI, all those platforms. This is sample research and testing which we conducted in IIT Roorkee. And in 2025, the conference was topic was building retrofits, and this year the date of the conference is 23rd October. It's a Friday, and the topic is seismic strengthening from shed to safe. We already released the preliminary flyer and agenda. I'll be sharing here as well, and also the final agenda will be defined or will be decided by July. I'll also be sharing with all the participants, and we really welcome you to participate, to contribute. And with this, I'll just end this. Let us come together to make a meaningful impact, because Seismic Academy's objective is engineering resilience through seismic excellence. With this, I will introduce our speakers for today's main technical sessions. So we have Engineer Jitendra Kumar Chaudhary with us. He is having over 5 years of experience in the field of standardization related to building materials such as cement, concrete, supplementary cementitious materials, testing of cement and concrete, pozzolanic materials, concrete mix design, design of concrete structures, earthquake resistant design, construction, and full scale testing of structures. So he is presently serving as a member secretary of Cement and Concrete Sectional Committee CED2 and Earthquake Engineering Sectional Committee CED39 in BIS. Important achievements includes comprehensive revision of earthquake safety standards IS 1893 Part 1, which is currently in process, revision of earthquake zone map of India, earthquake resistant design of base isolated building standard IS 1893 Part 6, 2022, comprehensive revision of blast loading standard IS 4991, formulation guideline of post earthquake safety assessment of buildings IS 18289, which is very much important for today's topic, and then landmark formulation of standard on packaged dry mix concrete IS 18685, formulation of new standard on ultrafine fly ash IS 19058, and revision of IS 6461, glossary and terms related to cement and concrete. His present major assignments is comprehensive revision of IS 456, which is a major code of practice for plain and reinforced concrete. Revision of IS 383 for coarse and fine aggregates of concrete, IS 13920 ductility design and detailing of RC structures. Revision of standards on seismic retrofitting of buildings and structures, and revision of IS 9103 chemical admixtures for concrete. And our next speaker, Engineer Barry Kaknix. Barry Kaknix holds an MSc in Civil and Structural Engineering and has been working in various technical roles related to fastening technology over more than 20 years. He is currently the Codes and Approval Manager for Hilti Asia Pacific, and also a member of Board and Vice Chair of the Technical Committee at the Australian Engineered Anchors and Fasteners Council, we call AFAC. In 2020, he joined the working group under the NE 029 Committee for Standards in Australia and has been actively contributing to the past two revisions of fastening standard, which is AS 5216. So with this, I would like to invite Engineer Jitendra sir to take care of the next session. Sir, the stage is yours now.
Thank you very much, Dr. Agomani, and I also thank Mr. Barry for joining today over this platform. And at first, I would like to thank all the organizers from the Seismic Academy team for inviting me in this webinar on seismic design of structures. And Yeah, I have been part of this Seismic Academy from last couple of years, and we have been closely working upon different standards also, and different workshops also. Last time also we have done one combined workshop with the NIDM team also. So yes, thank you very much for inviting me again in this event. So coming to the today's topic, which I am having is to give an overview of the earthquake safety standards which are prevailing in the country. So it has been basically, one is the prominent one, the IS 1893, one is the IS 13920 and 13935. So I will be a broad overview of all these sets of standards, and also what the concerned technical committee is doing in the further research areas under this field of earthquake engineering. That also I will elaborate. So let me just quickly share my screen. So can you share? Can you see the screen?
Yes.
Is it visible?
Yeah, it's visible.
Okay. Let me go to the full screen mode. Yeah. Okay. Fine. Uh, So before going to the standards for discussion, let me just quickly inform you about the evolution and genesis of Bureau of Indian Standards. So you are all aware that in 1919 year, so the organization has been established as the Institution of Engineers India, being the active committee of the British Standards Institution. And then in 1946, Government of India, through its resolution, has passed for the establishment of Indian Standards Institution, which is mainly broadly known as ISI. So, and thereafter, a few more amendments and impacts have been done. Then in 1986, under the BIS Act, which was the first act, came in 1986, BIS has been established as a statutory body for development of Indian standards in the country. And thereafter, BIS Act 2016, the BIS has been established and recognized as the national standards body of India for the development of Indian standards. These are some of the major key activities of Bureau of Indian Standards. The very first is the standards formulation, which you all are aware about the different standards which have been published and formulated by the Bureau of Indian Standards. Another ones are the product certification scheme. You all can see the ISI mark on various products which you purchase through the market. Maybe you can, if you just go and see around in your home also, you can see the ISI mark on most of the products and articles. So that comes under the product certification scheme. Similarly, we have the foreign manufacturer certification scheme, laboratory services, promotional and consumer aware activities. We are having a dedicated training center for the capacity building and dissemination of information about the standards at Noida. That is called as a NITS, National Institute for Training for Standardization. Then we are having laboratory recognition scheme, where we give the recognition to the various private and government laboratories which are NABL accredited. We are also having the hallmarking scheme, where we give the hallmarks to the various gold and silver jewelries, which has been recently been mandated by the government of India, that all the gold and silver jewelries to be produced using the hallmarks. Then we are having the management system certification, where ISO 9001, ISO 14001, and other management system certifications comes. And then we are having the last one is the compulsory registration scheme. Scheme is very similar to the product certification, but it mainly deals with the electrical and electronic goods basically. So these are the various and the organization comes under the Ministry of Consumer Affairs and Food and Public Distribution, Government of India. Now coming to the broad structure of BIS, so we are having hierarchy, which is you can see on the screen. The very first is the governing council. So governing council is led by our honorable Minister of Communication Affairs, Foreign Public Institution. Then comes the executive committee, which is being chaired by Director General of Indian Standards. So both governing council and this executive committee, they broadly deals with the policy, administrative, and advisory works. And then we are having the standards advisory committee, under which various revision councils are there. So as of now, we are having total 17 revision councils available in the Bureau of Indian Standards. Just like in any academic institution, we are having different departments for different disciplines. Similarly, we are also having the different revision councils. And under revision councils, there are technical committees and panels and working groups, which are the key people and key experts who are engaged directly in the development and formulation of the Indian standards. So this is a broad structure of the BIS. Now, the formulation of Indian standards are basically done by the national technical committees, just like any other standards development body across the globe. And presently, in the civil engineering department, we are having total of 37 technical committees, which are dealing with different subject areas and topics which are related with the civil engineering discipline. And coming to the today's context of seismic standards, we are having the dedicated technical committee CED 39, which deals with the formulation of standards on earthquake resistant design and construction, and also the testing aspects. So why the conformity to the Indian standards are required? What basically the provisions of Indian standards, how they will be useful? So basically the first thing is that it ensures to have a safe structural design. Any standard on design and code of practice, basically they provide the minimum requirements for making the design of that particular category of structure. Of course, the owner or the competent authority can go with further higher level of rigor, but the standard prescribes the minimum basic design requirements, which is to be achieved for having the safe structural design. Second one, we are having to have a robust structural configuration for in any case of our structure, whether it is a reinforced concrete structure, whether it is a steel structure, it needs to be mandated that it should have a robust structural configuration, which is able to resist the lateral loads, the loads which are coming, gravity loads, and all the other different kinds of loads which are coming and anticipated by the structure. Third is to ensure the resilient infrastructure. Once our standards will be resistant to the lateral loads such as seismic loads, wind loads, we will be able to ensure to have a resilient infrastructure in the country. And the fourth aspect is to ensure that the structure should have adequate ductility, which is one of the key parameter in having the resistance to the lateral forces on our structures. Now, just quickly informing about the standardization process, formulation process. This is very similar to what the other national standards bodies as well as the ISO, which is the International Organization for Standardization, which deals with the development of standards at the international level. So this formulation process is much a bit similar to the ISO development process also. So at the first we received the project proposal. So project proposal can come from anybody, any organization, any individual, any person who is practicing. And then once the proposal is received by the technical committee, so it basically gets scrutinized by the committee whether the proposal is having all the aspects, and if it is found suitable, then we can go to the development of the standard. If it is having any deficiency, then the committee again refers back and send that you can further share broad information or any supporting documents you are available. So once this project proposal is accepted by the technical committee, we go to the next stage, that is formulation of working draft, initial working draft, which is formulated by a couple of 4 to 5 experts of the work committee. Then once the working draft is prepared, it goes to the preliminary draft stage, where we invite the comments, feedback, and suggestions from all the members of the committee who are there representing in the committee. And then once the committee is having a broad consensus on the preliminary draft, then it moves to the next stage, which is called a wide circulation stage. Since standard is a national standard, which is going to affect the construction practices and all the industry and all the things which are going on across the country. So, and in committee, we are only having a small set of experts basically who are representing different organizations. So it is a very important role in formulation of any standard, that we need to take the feedback from all the concerned people. So that process, we do the wide circulation drafting stage. We open the document for a period of 2 months, 3 months, depending upon the importance of that particular standard, and we invite public commenting from all the relevant stakeholders and academic institution, R&D bodies. Anybody can provide their feedback and suggestions. So once the comments are came on the wide circulation drafts, it basically reviewed and scrutinized by the by the technical committee. And once all the comments have been resolved and a final consensus has been reached among all the members of the committee, the document is basically finalized, and the final draft is basically sent to the division council for its adoption, and then finally the publication of the standards gets released. So this is a broad process about the standardization, what we adopt at Bureau of Indian Standards, and it is generally adopted at the other standards bodies, as I already mentioned. Now, coming to the committee which is dealing with the formulation of standards on earthquake-resistant design. So this is the committee which has already informed CED 39, and the details of the composition is there. You can see we have representatives from the R&D bodies, academia, individual experts, associations, government agencies, public sector undertakings, and industry associations also. So these are all the key experts which are giving their feedback and which are helping us in the development of the standards. Anybody who want to volunteer in the formulation of the standards, they can always write to BIS for their nomination. The committee will consider, and we will see where your expertise and your knowledge can be basically recognized and where it can be utilized. So there we will inform you about that particular decision, what has been recommended by the committee. Now, why earthquake-resistant design is essential? So, if you can go to the seismic zonation map of the country, so you can see that around 61% of the Indian landmass is prone to moderate to severe earthquake shaking, means the regions which are falling in zone 3 to zone 5 and 6. And there are, you know that in the country, there is a huge amount of non-engineered building stock in the country, which is available, and where even leave aside the earthquake resistant design features, the basic design requirements which are recommended by the standards and codes, they are also not utilized. Then the third aspect is the rapid urbanization and infrastructure development in the country. And of course, in order to ensure disaster resilience and preparedness. So considering all these aspects, it is very much required that earthquake resistant design should be taken care while developing a new structure, and also the structures which are already built, timely monitoring and review and assessment of those structures, so that a proper retrofitting schemes can be selected. So there is a very common saying that earthquakes don't kill people, but buildings do. If the buildings do not have the features which are able to resist the lateral loads, you will not get sufficient time to escape from your buildings or houses in the case of earthquake shaking. So that's why it is required that earthquake resistant design should be incorporated while designing any structure or the houses. So what the basic philosophy of the earthquake resistant design, which we engineers are basically practicing from past decades, so many decades. So basically, we categorize the shaking which is coming from the ground during an earthquake event into 3 categories. One is the minor shaking, one is moderate shaking, and one is the severe shaking. So minor shaking is very frequent. If you open the Bhukosh app of National Center of Seismology, or if you visit the website of National Center for Seismology, so every day you can see there are small earthquakes of magnitude 1.5, 2.5, 3, 4. So all these different magnitudes earthquakes are coming every day. So these shakes we consider in the minor shaking, which are very frequent, which is coming every day. Maybe in one day it can come once or twice or thrice, basically. So for such minor shaking, there should be no structural damage and no non-structural damage to the buildings. Then the second level of shaking is called as a moderate shaking, where some level of non-structural damage would be there, but there would be no structural damage. And then the third comes as the severe, which is severe shaking, which is having magnitude more than 6 or 7. That is very infrequent, but it will lead to structural damage, non-structural damage. But our philosophy should be the structure in any case should not collapse. Structural damage, non-structural damage can occur. Maybe they will be repairable, they can not be repairable, but in any case, the structure should not collapse. So that is the primary intent of the earthquake resistant design philosophy, to prevent the collapse of a structure and thereby to protect the loss of human and animal lives. So this is the basic philosophy which the engineers generally adopt during the earthquake resistant design. Now, coming to the standards which are dealing with the earthquake resistant design. So this committee have already informed about this one, and as of now, we are having total 16 standards which are existing on the seismic design. So these are a list of some of the Indian standards on the earthquake resistant design which are available. So you know that the parent seismic design code in the country is IS 1893, and various parts of 1893 are already available, and so those you can see. And apart from IS 1893, we are having IS 4967, which has been recently, last year, it has been revised. That is the instrumentation of the dam projects. Then 4991 part 1, that is on the blast resistant design, that also has been recently revised. And then various series of standards which are available for the seismic strengthening and assessment, basically. Then coming to the recently published standards, IS 4967 already mentioned. 4 on the industrial structures, including stack-like structures, has been revised in 2024. And of course, the blast resistant code, that is also revised in 2024. Coming to okay, so now, so these are the standards which are already existing, already available. You can download from the BIS website. Now, what the committee is currently doing, so we are in the process of making the harmonization of the various earthquake codes. So in the process of harmonization, what we have done, that the committee has divided the standards into 3 broad categories. One is IS 1893, one is IS 13920, and one is IS 13935. So IS 1893 will be dealing with the estimation of earthquake hazard and analysis of structure. It will help you to estimate the hazard which is coming from the ground motion and all the parameters which are involved in the calculation of the earthquake forces and also the load combinations as well. So from 1893, you will get the forces which are coming on your structure, that we call as the earthquake demand. Now coming to IS 13920, that will deal with design and detailing of the structure. So design and detailing means once you have estimated all the loads which are coming on your structure, now you have to design your structural members, your beams, columns, slabs, reinforcement, detailing, everything to adhere to the demand which is coming from the earthquake forces. So that's why we call it as IS 13920 as the capacity, basically estimating the earthquake capacity. Now IS 13935 will be dealing with the safety assessment and retrofitting of the structure. And remember, this is only dealing with the earthquake safety assessment and retrofitting, not the general retrofitting. I would like to inform that there are other technical committees in our civil engineering department, and they have taken up the subject on structural retrofitting of structures to consider the other aspects which are required for the retrofitting and means deterioration of the concrete structures. But IS 13935 will be dealing with the seismic safety assessment and retrofitting. Now, under all these three verticals, we have divided the standards into various parts basically. So part one will be dealing with the general provisions. So general provisions will be applicable to all types of structures, all categories. Then we are having the liquid retaining structures, both elevated as well as ground supported structures. Water tanks will be covered over here. Then part three will be dealing with the bridges. Part four will be dealing with the industrial structures, facilities. Part 5 will be dealing with the buildings, as buildings is one of the important category of a structure. Part 6 will be dealing with the base isolated buildings. Part 7 will be dealing with the long distance pipelines. 8 on coastal structures, then steel towers, tunnels, and earthen embankments and earth retaining structures. So as of now, the technical committee has divided the standards into these three verticals, covering all these 11 parts. Okay. Then, okay, so now coming to the first vertical, that is IS 1893 part 1. So part 1 2016 is already existing, and in the currently ongoing revision of IS 1893 part 1, one document has already been released in 2025, but because of the representations which we have received and from the directions from Government of India, so the committee is currently reviewing the provisions of the standard, and very soon we will come to the next version of the document. So what the proposed changes which are going on in the ongoing revision is that first is the introduction of the revised seismic zonation map of India based upon the probabilistic seismic hazard analysis. That is, in short, we call it as a PSHA. PSHA is basically an internationally accepted hazard assessment approach, which is used to estimate the earthquake hazard at a specific ground site basically. So most of the countries have already accepted and added the PSHA approach of estimating the hazard assessment in their seismic codes, and we are also in the line of coming up with the PSHA introduction in the seismic standard. Second one is the provisions related to buildings will be covered in part 5. So that I've already mentioned, just the last slide basically. Then design horizontal acceleration coefficients have been specified for each earthquake zone for use in the strength and serviceability design, just like whatever is given already in the previous versions of IS 1893. Similar we are having this time also. Acceleration response spectra have been defined for natural period up to 10 seconds, so as to include the long period structures also in the earthquake design. Earlier in the 2016 version, we were having the spectra defined up to 6 seconds, but now it has been enhanced up to 10 seconds. Then method of estimation of the soil flexibility, the bearing capacity of the soil modeling, liquefaction potential of the soil, taking consideration into the stiffness and soil spring model. So all these the provisions which are related with the geotechnical aspects and the soil modeling, they are also being revised and they are also being added. And the provisions, this is basically introduced for the very first time in the seismic code, provisions related to the earthquake protection of the non-structural elements in the standard. So non-structural elements, basically the attachments, the appendages which are attached to the ceilings, the walls, and to the walls. So basically, because generally the earthquake design standards, they mainly focus upon the safety of the structural elements, but at the same time, it is also important to ensure the safety of the non-structural elements as well. So that's why the committee thought that let us introduce the provisions for the safety of non-structural elements, because these elements constitute of about 70 to 80% when we go to the critical structures such as hospital buildings, medical care facilities. There you can see, leaving aside the structural elements, most of the parts of any room or section or hall, they are mostly constituted by these the non-structural elements. So that's why ensuring their safety is also important. So present seismic zonation map of India is basically the one which is showing in IS 2016 version of IS 1893. And the present zonation map introduces the zone 6. And of course, it is basically currently under review. And we will very soon, we will be coming up with the revised version of the standard. So till then, once the revised version of the standard is not applicable, IS 1893-2016 will be applicable in each and every aspect. Now, the very four virtues of earthquake resistant design of structures, which are generally considered during the design. One is the structural configuration, that is the robust structural configuration. Second one comes to the stiffness, then strength, and the very important is the ductility, to ensure adequate ductility in the members of the structure. Okay, so this was all about IS 1893. Coming to IS 13920, that is on dealing with earthquake resistant design and detailing of the structure. As I already mentioned that our demand, earthquake demand will come from IS 1893. And now for that demand, we need to design our structure. So the capacity design of our structure will come from IS 13920. So this standard will provide the requirements for the design and detailing by capacity design and detailing of the select structural elements, connections, and joints of all types of structures. So, and it will be providing the details of the construction for masonry, concrete, and structural steel. And the provision of the earthquake safety standards will be added to the ones which are already specified in their respective basic design course, like IS 1905 is available for the masonry structures, IS 456 is available for the concrete structures, and IS 800 is available for the steel structures. So IS 13920-2016 is currently in practice and it is presently existing. And then, but 2016 version was only dealing with the reinforced concrete structures. And IS 18168, which has been published in 2023, that was dealing with design and detailing of the steel buildings, because we have received various feedback from the industry and associations that we should have a capacity design standards for the steel buildings also, because as of now only RC structures have been covered in IS 13920. So that's why the committee has formulated in 2023 for the design of steel buildings. So in the ongoing revision of IS 13920, we have divided that particular content of the standard into 4 different sections. So section 1 will be covering the provisions which are applicable to all the types of building typologies which are available. Section 2 will be dealing with the masonry buildings. So in the masonry section, we are having the unreinforced masonry buildings and houses, and we are having the confined masonry buildings, and we are also having the reinforced masonry houses. And what are the provisions which are available? So that also we will consider in the masonry buildings. Third, we'll be dealing with the concrete buildings and concrete structures. And fourth one will be dealing with the steel buildings. So the next, the revised version of IS 13920, the part which will be dealing with the buildings, that will be more elaborative and more exhaustive, so that any user who is engaged, any consultant or engineer who is engaged with the design of buildings, he will be having one standard only, and he will get all the aspects related to the buildings of any typologies for their convenience and use, basically. So that was the basic philosophy of basically dividing the building as a separate part from part 1, actually. Okay. Then, of course, the revision of 13920 and 13935. So as I already mentioned, that 13920 will be covering the design and detailing aspects, and 13935 will be covering the assessment and retrofitting structures of the parts. Okay, before moving to IS 13935 details, let me just quickly just talk about some different lateral load resisting system, because today we are discussing about the seismic design and seismic philosophy. So let us understand some things about the lateral load resisting systems. So in these systems, we are having the braced frames, which are very commonly you can see in the steel buildings, the railway bridges, and steel bridges, so providing low to mid-rise buildings also. Then we are having the rigid frames or the moment resisting frames in low-rise buildings, both concrete as well as steel, you can see. And different, we are having different categories in the moment resisting frame. Or we are having ordinary moment resisting frames. We are having special moment resisting frames. And then also along with the moment frames, we are also having the other structural configuration that we call it as a dual systems. And then we are having the reinforced concrete shear walls, which are basically added in the mid to high-rise buildings, the tall buildings basically. So all of these are the common lateral load resisting elements which are generally incorporated in the buildings and the structures. And they should be properly designed and detailed for the ductility requirements to enable perform the effects of earthquake and to resist the lateral loads which are coming on the structure. So for the design and detailing, I've already informed that we are having IS 13920, which provides the recommendations. So these are different types of braced frames which are commonly used in the buildings and the structures. So, and the design and detailing guidelines are already covered in the IS 13920 also for the reinforced concrete structure, and for the steel buildings, it is covered in IS 18168/2023. Now, for the rigid frames, that is for the moment resisting frames. So provisions are covered in IS 1893 Part 1 2016 and IS 13920 2016. Then coming to the shear walls, basically. So these are the RC shear walls, which basically begins from the ground and it directly continues up to the top level of the building or the structure. And shear walls are also provided in various different shapes, rectangular, L shape, C shape, depending upon at which location of your building or structure they have been added or included. And then shear walls have to be located symmetrically to take the best advantage of their combined action. So symmetrical orientation of the shear walls will help in reducing and avoiding the unnecessary the forces which are coming, and also to reduce the torsional effects which are coming on the building. So that's why symmetric location of the shear walls along the perimeter of the building is very much desirable. And symmetry is always performs the best in case of earthquake loading as much as possible. Of course, we know that in the present scenario with the rapid urbanization and development, we are now putting more importance and to the aesthetics, of course. But in the cases where you are having the opportunity, so you try to make the structure as symmetrical as possible. But of course, for the unsymmetry in case of both horizontal direction as well as vertical direction, IS 1893 provides the recommendation how to deal with those types of irregularities in the vertical and horizontal direction. Okay, so now let us come to IS 13935. So that is basically dealing with the safety assessment and retrofitting of the structures. So it basically provides the general principles of earthquake safety evaluation of the existing structure, and also the earthquake safety assessment of the new structures which are being designed basically. So major changes which are being made in this particular revision. So in this revision of IS 13935, we have introduced 5 levels of evaluation of a structure, which we generally call as a 5-level telescopic evaluation of the structures. The very first level will be very common one, very easy. That is basically based upon the rapid visual survey only, visual screening. And then moving to the next levels, it will increase the level of rigor. It will increase the level of calculations and things which you need to consider for the assessment. So in this way, we have introduced the 5 levels of evaluation. The structures which are yet to be built also, they are brought within the scope of these standards. Hazard levels are specified for the assessment depending on the age of the structure, and load combinations are used while evaluating and retrofitting the structures. Then, of course, the ground motion and non-linear methods of analysis have also been prescribed in further details compared to the earlier version of the standard. So this is basically the 5 level of telescopic evaluation of the structure. So the very first one is the field level evaluation, which is a qualitative method of evaluation, which is based upon the rapid visual survey. Like you go to the site, you observe the buildings, and you note about the things which you can directly see through your eyes, basically, that whether how the deterioration has been happened in the beams, columns, slabs, how much cracking has been done, what kind of damages has been done. Okay, what is the means building typology, whether it is a steel, concrete, masonry building, and which type of soil on which the structure is lying. So all this kind of assessment basically comes under this field evaluation, and we have also given the basically the detailed form in which all the assessment things to be put down, and the checklist is basically given over there. And depending upon that checklist and all the evaluation parameters, we have given one index, basically performance index, and depending upon that performance index, basically we will take the decision that whether the structure can be can basically go to the retrofitting or strengthening, or we need to go for the demolition of the structure. In any case, the demolition is the last option for any kind of building or structure. We always try to go that if there are any chances or opportunity that we can strengthen and improve the basically the performance of the structure, so that its life can be further extended to some more years. So that all aspects come under the field evaluation. Next comes the basic level of evaluation. There you need to do little bit hand calculations. Some things are there. Then code-based evaluation, where the conformity with the relevant standards should be there for the evaluation parameters. So both basic and code-based level evaluation, there you have to do the linear methods of analysis are basically recommended over there. Then comes the dynamic level of evaluation, and the last and the not least, the non-linear evaluation, that is involving the very much rigor, very much quantitative evaluation for the assessment of the structure. So these 5 level of evaluation procedures have been included in this revision of IS 13935. Of course, all the details about this, how to carry out this evaluation and assessment things, and what parameters which are to be chosen, all the different forms and things, everything has been included in the present revision of IS 13935. Now, the other new standards which are under development. So one is basically the full-scale prototype structural testing of structures for the earthquake effects. So this basically has been adopted because in the field of earthquake engineering and science, we are seeing that with each passing year, we are having so much of latest technological developments, new technologies which are coming into the construction industry. But at the same time, of using all those new technologies and emerging things, we also need to assess and measure the performance of such new technologies, that in the case of earthquake resistant design and the regions which are very prone to earthquake shaking, how much is the performance and feasibility of using such new and emerging technologies are there in those regions. So in order, and as of now, we were not having, although there are many laboratories and R&D bodies in the country which are already doing the prototype and structural testing, but as of date, we were not having any standard which is giving the requirements of what type of test to be done, and what type of specimen size, prototypes, and all the things which need to be taken into consideration while doing the testing of the structures. So those kind of recommendations were not available. So that's why the committee thought that let us come with the provisions in a standard where we can give the guidelines to the laboratories and the industries, that these are the things which are to be considered for the structural testing, and that with that philosophy, this particular proposal has came out. And I'm glad to inform that this document has been finalized by the Earthquake Engineering Technical Committee, and very soon it will be published. Within a couple of months, it will be published and available. So it will also help and further enhance the building and establishment of testing infrastructure in the country to do the testing for the seismic loading. So that is one standard which is under publication. And the next one, we are coming up with the document on the earthquake energy dissipation devices. So basically, the energy dissipation devices, like the provisions and the specifications about the seismic dampers, which are available. Many types of seismic dampers are available, but as of now, just like structural testing, we don't have any recommendation for the energy dissipation devices. So in that area also, the committee is looking, and we will very shortly we will start working upon this particular area. So any colleague or participant who are there who want to contribute in this particular area, so they can write to BIS, and of course the committee can consider their expertise and information. Then so these are all the things which are basically done by Bureau of Indian Standards. You know that we are the national standards body, which is mainly involved in the establishment of the documents. But the implementation of the document is the second key aspect, which is very much required to fulfill the requirements of the standards, the provisions of the standard at the field level. So in order to fruitfully implement the provisions of the standards which are laid down by the technical committees of BIS, so in that way, the role of the states becomes very much prominent and very much required. So what actions which are required from the states bodies? So one is basically the capacity building. So capacity building is basically involves the technical education of the principles of engineering and science to all the practitioners, to all the people who are engaged in the building design and construction. And this should be a regular and dynamic process. Basically, time to time, the authorities should carry out this capacity building program so as to improve the knowledge and understanding of the people and who are engaged in the structural design. Then continuing the education of engineers, and we should have a licensed engineers. Many states have already introduced this concept earlier, and this time also, and this should also carry on so that the structural engineers should be competent enough to carry out the structural design and analysis, all those things, and the training of the executive agencies and the government bodies also. So all these fines basically come under the category of capacity building and training programs. Second aspect is basically the robust enforcement mechanisms in the country. So municipal offices and municipalities should conduct the peer review of the structural designs of all the buildings which are submitted by the designer, so that it should be properly vetted, and then of course the construction phase can start, of course. Then comes the building regulations. So robust building bylaws for the land use planning and safety norms should be there, and building reference to the building codes and standards should be added in the building bylaws, so that whenever the bylaws are basically, whenever any projects, large projects or small projects are basically developed using any building bylaw, so the provisions and recommendations of the standards should be taken care of first. And of course, as I already mentioned, that full-scale tested technologies should be used basically, so that for that one we will having a broad confidence that such kind of technology will help in ensuring the better resistance to the lateral loads and forces basically coming on the structure. Now, what are the various instruments which are used for the building regulation? We are having the Town and Country Planning Act and Development Act, which are there, which give the policy and administrative guidelines regarding the town and country planning. So those act and regulations can refer the building codes and building standards in their acts. Then we are having the master and zonal plans, layout plans of every state and districts. Then we are having the municipality and municipal corporation acts, which are giving the guidelines, and of course the building bylaws, which are giving the regulations for the building design and construction. This is basically a one kind of a publication which has been greatly worked upon by BIS and NDME, National Disaster Management Authority, and we came up in 2000. This was published in 2021. So this is basically simplified guidelines on earthquake safety of the buildings from the National Building Code of India 2016. So this is a book basically which gives kind of information. It is basically a dialogue between two characters of this book, where the girl is asking the questions about the earthquake safety, the seismic zones, how to design the structures for the lateral loads, all those things, and his grandfather is basically giving his her all the answers basically. So it is very a good book. You all can just have a go through of this particular publication, and you will get to know more and more insights about the earthquake resistant design and seismic zoning basically. So these two characters, Chacha and Muni, basically they are the covering the whole dialogue between both of them. Okay, so this is a very much important thing which I would like to inform to all our audience, all the participants who are joined today, that this is a recent publication of Bureau of Indian Standards, the revision of the National Building Code of India. So this is SP7 2026 National Building Construction Standards. So this is the current revision of the document, and here basically the two, of course, as the earlier version is also having two volumes, here also we have two volumes. Volume 1, which is covering the introduction and the recommendations regarding the building materials, structural design aspects, which are covered under these 8 sections, where the section 1 is dealing with the loads and load effects, section 2 on the soil and foundation, then we are having timber and bamboo, section 4 is dealing with the masonry, 5 on the structural concrete, 6 on the steel and composite construction, then 7 on the prefabricated concrete construction, then section 8 on the glass and glazing aspects. Then volume 2 is basically dealing with the building services, where all the lighting and natural ventilation installations, air conditioning, HVAC basically, acoustic, soil, sound installation of lifts, then plumbing services, and of course the aspects of fire and life safety. So I would request that all of you can just go through this the revised document on this national building construction, and you all can just download this from the BIS website. It is already available on the front cover. It is free of cost, so all of you can download your own copy and have a go through of this revised publication, which has been done by a lot of experts who have been engaged in this revision exercise, which has been taken around more than 3 years basically, and now we have came up with the new publication of this one. And for getting the information about all the various standards on design, code of practice, and materials, and specification, test methods, all those, and not only to cement and concrete, but to other building materials also. So here is the latest program of work, POW, and I've already given the link also in the slide. So you all can just download this program of work of Civil Engineering Department, and you will get to know about all the standards which are presently available with this department. And if you think that any new topic or new subject or any existing standard which should be taken up for revision or which requires any amendment or correction, so you always can write to us. So the committees can look after that aspects, and we will do the necessary action as required from our end. All of you can just download your own and indigenous copy of the Indian standards at free of cost from this standards BIS bsbh.com. This is the e-sale portal of Bureau of Indian Standards. So you just need to make one-time registration on this website, and you can download all the Indian standards as well as their amendments, and also the special publications you are able to download. If you are having any trouble with the downloading, you can write to us. We will provide you the soft copy. So these are the references which has been taken in preparation of this entire presentation. Then a little bit information about the BIS Care app. This is so this year we have introduced the I think the third version of this BIS Care app. So here you will get all the information about the standards, all the information about the various product standards which are available, and you can also check for the licenses basically which are there on the products basically, and also the hallmark jewelry also. So this is a care app is available on both Google Play Store as well as the Apple Store. So you all can just have a download and you can just quickly go through the various features of this care app, so that it is a very basic, basically very easy interface that I don't think that it will create any problem to anybody of you. So you all just can go through and just have a download of this one. Okay. So for any queries or suggestions related to any Indian standard, whether it is a existing Indian standard, or as I already mentioned that if you want to submit any new proposal for any new topics which you like to think that this can be considered for standardization, and as on date we don't have any standards available on those particular topics or subjects, so you all always can write to us at ced@bis.gov.in. That is basically our departmental ID. Or if you are having any suggestions regarding the earthquake standards, you can directly write to us at ced39@bis.gov.in. So whatever your queries or suggestions will be there, we will take up to the earthquake engineering technical committee, and whatever the recommendations that will be given by the committee, we will take up, and any action which is required from our end, that we will definitely take up. So that was all from my end. Thank you very much, all the participants, all the listeners, for your patient listening. Thank you very much.
Thank you, Jitendra sir, for the informative and insightful session. You shared a very good insight how BI structure is and what are the standards already under development and upcoming. I think many people will be interested to join in the committee and contribute from industry as well as from academia with expertise from different fields. I mean, we can discuss some questions like the link which you shared as services.bis.gov.in. Some people are saying that website is not opening. Maybe as you mentioned, Jitendra sir, they can write to BIS, right?
Yes, sure.
Yeah.
I think we can again share them the link, so that working link, so that they can refer to the directly go to the website only.
Yes.
Or if you are having any trouble, you can directly go to the our BIS homepage basically, and there is the option for download Indian standards. So that link will directly take you to over there basically. So there also you can just go through.
Also, there is a question that how to join the committee in BIS. That is also another question.
Okay, so for joining, you can just send your CV as well as the brief resume, and in which basically topics or subjects you want to work upon, you want to contribute in which topics. That is very important, because technical committee involving all the stakeholders will be very difficult, because we already have a fixed quota we can that in which basically concerned project or document where your expertise will be very fruitful and aligning. There we can invite you for having your contribution. So you can always write to at as I already mentioned that both the links, you can share your expertise over there, so the committee can take necessary action on that one.
Yes, thank you, sir. We will also be posting the links here so that participants can click on that link and can and also can send the details to the mail IDs. Yeah, thank you, sir. And I will go to the next session, which is based on the seismic design of structural and non-structural connections using post-installed systems. And we have a global speaker, Engineer Barry Kapnix, with us. I would invite Engineer Barry Kapnix to take over the stage. The stage is yours now.
Thank you very much, Agamoni, and thank you for the introduction. Good afternoon to everyone. It's a pleasure to be able to present here today. As Agamoni said, I've been working in the industry for 20 years, and my special field of interest is especially anchors and how connection can contribute to increase the seismic resilience of buildings. So today, from the broader perspective after Mr. Jitendra, we will zoom in and we will focus on critical connections within the buildings. To start with, obviously the importance of earthquake engineering probably doesn't need much introduction. We know that there are many instances of major structural failures, of full building collapses as a result of earthquakes globally. Here I just brought a couple of examples, two from the India-Pakistan region and one a little bit closer to my birthplace, Eastern Europe, from Turkey. These all basically tell the same disaster outcomes, namely the loss of life, a great amount of injuries, as you can see, and also a very significant damage bill post-disaster. I reckon we all agree that especially in the case of India, earthquake design is critical. If my understanding is correct, in the case of your country, nearly 60% of the Indian land mass is vulnerable to either moderate or critical seismic hazards, especially if we talk about the northeast region, as we saw it in the seismic hazard map, or the Himalayan belt. These are extremely important considerations. So all in all, implementing adequate structural engineering principles is vital to prevent catastrophic building failures, the loss of life, as well as to ensure a quick and rapid post-disaster recovery. So the statistics show that basically on average, there is at least one earthquake happening every day globally where the general public actually notices and reports about. For us engineers, we already talked about seismic demand, and seismic risk is a very similar definition, but seismic risk is probably a little bit broader one. So I just want to spend a minute quickly recovering what the seismic risk is, which is essential in our engineering practices. We define seismic risk as a combination of two things. One is the actual hazard, and the other one is the impact of the disaster. And the hazard is a thing that we cannot really control. Earthquakes are natural occurrences, right? So we cannot really change that. So we need to live with this. What we can control in order to reduce the seismic risk, if we can reduce and mitigate the impacts of the disaster, this can make a significant difference. And this is what we are going to cover in today's presentation as well. Of course, it is critical to clearly define, quantify, and communicate the seismic hazard. We saw some great examples from the previous presentation about Indian standards and the seismic hazard map being updated. These are great tools for engineers. What is not so obvious, though, how we can reduce the impacts and the vulnerability of these structures. And anchors are no exception from these. So we need to apply the adequate design methods, choose the right materials, and in cases where it's required, we need to be able to strengthen and retrofit our structures. This is a very common and well understood slide, which shows the various stages of disaster impact. What we see in most global codes, and I'm coming from Europe, but also worked half of my professional life in Australia, and codes are very, very similar in terms of the primary goal of the code is obviously protecting human lives, but mainly to avoid the full collapse of structures. What we see, however, the more forums we join and the more we discourse with seismic experts, that there is a welcome shift in the mindsets. And I cannot emphasize this enough. This shift needs to happen everywhere, and it needs to become part of our daily engineering practices, that from purely collapse prevention, we need to shift our focus to a more performance-based design approach. And when I say performance-based design approach, we need to bring in principles which basically help to reduce the downtime, the cost needed after post-disaster recovery. That's becoming equally important. Why I say so? Doesn't matter which country we go, we see that the built environment, the built assets, the value is increasing. There is inflation everywhere. Labor costs are increasing. The economic impact is becoming greater and greater. When we talk about these disasters, we can talk about obviously impact on human life, injuries, but it's equally important to talk about societal impacts and economical impacts as well. And in modern seismic engineering, I believe that one of the very right approaches, if we adopt a performance-based design, and the optimal performance is somewhere in between protecting lives, but also shifting towards immediate reoccupancy or significantly reducing the time required after an earthquake when the building can be reoccupied. And luckily, we see newer guidelines coming out, especially in Australia. There is a positive trend now where we see evidence of this new mindset basically coming into effect as well. There were some great global studies done in the past which talk about earthquake resilience. And talking about earthquake resilience, it was showed in multiple countries that, for example, in order to make a building 50% more earthquake resilient, it doesn't take spending 50% more on the building cost. It only takes somewhere between 3 to 6% more spending to make a building 50% more earthquake resilient, if it makes sense. So I believe that this is truly a good investment, and there are more and more bodies who actually share these views. For example, just to mention the insurance cost of buildings going up, and insurer companies are actually appreciating these extra investments and better engineering to make our built environment more resilient against natural disasters. Today we are zooming in. I promised to you that my favorite building products are fasteners and anchors. So we talk about post-installed fasteners mainly today, which are connecting either the primary structural components or sometimes the secondary structural components. We simplify these and we just call these anchors, either structural anchors or non-structural anchors. What I want to also emphasize here today, that from the seismic engineering point of view and from the risk point of view, they are equal. We don't distinguish whether it's a structural connection or non-structural connection. Where we draw the distinction is whether the connection is a safety critical one or it's a non-safety critical one. Structural and non-structural, equally important, and I will explain later why this is the case. I brought a couple of definitions today. So how do we define safety critical? This is taken from the latest edition of the Australian Anchor Code, which says that fastenings whose failure may result in collapse or partial collapse of the structure or endanger human life or result in the loss of functionality of higher importance level buildings or causing considerable economic loss. Please note the shift in the engineering mindset from pure collapse prevention and human life protection. We are going towards reducing the economic loss as well as maintaining the assigned building function, which all ties in what I said previously. We want to reduce the time and cost of recovery, reoccupancy. That's very, very important. Structural, non-structural, secondary question. Why I'm saying so? These are some of my favorite photographs. I believe these are from the Christchurch earthquake 13 years ago in New Zealand. And you can see some of these photos taken show that the building is mainly okay from the structural point of view. But what happened inside the buildings is a tremendous level of non-structural damage. Various building service equipments, pipes, interior finishing items, suspended ceilings, partition walls, MEP fixings and pipe work are collapsing. Not sure if you know the origin of seismic anchor qualification. It started in the United States after the 1994 Northridge earthquakes. And this was a major disaster event happening in California in the US back in the mid 90s. What happened there? They noticed that significant building damage happened to critical infrastructure, for example, hospitals as well. And they had to fully shut down and evacuate 11 hospitals in the region. Just imagine, after a major earthquake event, people are getting rescued. They try to deliver patients to the hospitals, and 11 hospitals are not operational. Even worse, 6 out of those 11 hospitals were unoperational because of the failure of non-structural components. For example, burst pipes flooding the wards, or even cable trays collapsing and the electricity and the power fully going out in these hospitals. This is a secondary impact, but actually the failure of the non-structural components can affect human lives. What it can also do, it can, as I said, render the building function not operational. And this can secondarily kill people as well. Just imagine about maintaining escape routes if the emergency lighting is out. If these building services are not operational, emergency egress is no longer operational as well. Let's talk about the third type of effects of the failure of non-structural components. You can see all these office buildings and the societal impacts it can make. It renders residential homes uninhabitable. It renders workplaces unoperational. And of course, beside the societal impacts, there are very great economic impacts as well. So what can we do when it comes to these connections, and why in the US they started to put a lot of research in the mid 90s into fastenings? Because they realized that actually the failure of the non-structural components is a bigger issue and it's a bigger risk than they ever expected. So what they did, they looked into what the seismic demand is really on fastenings and anchors. And here we need to talk about two things. And in the engineering practice, we will actually separate the selection of the anchors from the design verification of the anchors. These are two separate steps. For the selection of the anchors, we don't just select any anchor. We need to make sure that the anchors are actually tested against the changes in the loading pattern, which means dynamic loading, either a pulsating tension force or an alternating shear force. But what else is happening as well, and this is super crucial, there are changes happening in the base material itself. The changes mean cracks, concrete cracks develop. When we drill a hole for a post-installed anchor, we weaken the base material. Actually, we create a notch effect. So when moment reversal is happening to the structural part, for example, a concrete slab or a concrete wall, the moment is cycling, it's reversing. These anchor holes act as invitation for these concrete cracks. And these concrete cracks, oftentimes, they don't just open, but they actually start a cyclic movement. They open and close. Just imagine a friction-controlled anchor is being installed in one of these holes, and the hole all of a sudden becomes 1 millimeter larger. You lose most of the friction, you lose most of the grip of the anchor, and the connection fails. So therefore, we need to make sure that the anchors are properly qualified and tested against these change conditions. In today's presentation, I'm going to talk about anchor qualification against seismic actions. And the next presenter, Ms. Agamoni, she's going to talk about anchor design based on the new Indian code of practices that were recently released to the industry. So here are the steps which are super important to understand how the anchors are qualified. The recently published IS 1946 Part 3 for bonded anchors and Part 4 for mechanical anchors, these include qualification criteria based on the best global practice, which is the European guidelines. In Europe, we call these European assessment documents. This one is for the mechanical, the other one is for the chemical anchors. What was done very well, in my opinion, for India, where the seismic risk is at least moderate, but very often high, India decided not to go with the lower category, which is called category C1 in Europe, but India voted to only adopt the best and the state of the art and the more demanding anchor testing protocol, which is the seismic category C2. I will show you what this C2 testing actually entails. So whether you open up an European document or the new Indian codes, it's very important to understand that seismic anchor in India equals to category C2, the more severe category. And that's the right decision to do. Just to show you some of the tests that the anchors must undergo during seismic qualification. So first of all these anchors must be tested in cracked concrete based material. Cracked concrete is a must. And when we talk about cracked concrete, there were multiple studies made globally, and they looked into realistic behavior of realistic structures. And they had to draw the line somewhere. They said that, okay, we not allow anchors to be placed in and right next to the seismic hinges because it's just almost impossible to quantify those. But outside the seismic hinge regions, typical concrete structures typically don't develop wider cracks than 0.8 mil. Of course, in the seismic hinge regions, bigger cracks will happen. It's very hard to quantify those. What we can do, we can basically regulate what's happening outside the seismic hinges. And we said that, okay, a nice and strict requirement for these anchors. In a static case, it would be around 0.3 mil. In a seismic severe case, we go up to 0.8 millimeters. Just imagine, again, friction controlled or expansion anchor is set in a hole and the hole diameter becomes nearly a millimeter larger. Plus you add dynamic loading, and you can truly imagine how severe this is for an anchor to operate and have a reasonable remaining capacity. So this is exactly what we are doing during the testing. So there are reference tests, and then in cracked concrete, where the crack is gradually opened wider and wider, starting with 0.5 mil, then up to 0.8 mil, they are actually increasing the load as well at the same time. Then they test the anchors in cracked concrete holes for alternating shear load as well. And the final one, where most anchors actually do fail, and then they have to repeat the test at a reduced load level, is what we call the C2.5 protocol, where they actually start to move, open and close the cracks, and they also increase the load at a certain amount of time. I will show you how this actually happens. So this is the crack cycling protocol. You can see that the cracks are opening wider and wider. This actually mimics moment reversal on the structural element. So opening and closing cracks. And at the same time, compared to the reference test, they established that we start with 40% of the maximum reference capacity. Then at a certain point of time, we increase this up to 50% of the maximum static capacity. What happens? A lot of the anchors actually pull out at this stage. The anchors that don't, they can go on, but there is one remainder test. So after the static test and the cyclic crack test, there is also a residual capacity test. Just remember what I explained about post-disaster recovery and making sure that the buildings that we build and design, they are actually reoccupiable in a short amount of time. We want to ensure that these fastenings are actually surviving the severe earthquake and they actually remain operational. They can be used further and their design life can be extended as well. That's again very important in modern seismic engineering. So after this major earthquake event modeling and testing, the anchor still must be able to achieve 90% of its original static capacity. I reckon that's quite significant, and that really well underlines what I just said at the beginning of my presentation. So that's from my side with regards to the qualification of seismic anchors. I'm very happy to answer any questions either now or towards the end in the Q&A session. And the next presenter, Agamoni, she's going to take you through the practical aspects of anchor design and verification based on the latest Indian codes. Thank you very much for your attention.
Thank you, Buzz, for the excellent presentation, delivering such insightful technical topics and the reason why seismic design is important for connection from global perspective as well. We will take the questions at the end of the session. I will take just some few minutes, 3-4 minutes. Hope my screen is visible.
Yes, it is.
Yeah. So I'll just discuss in brief what is the relation between IS 1946, which is launched last year, the first Indian standard for post-install anchor, also with the Indian seismic standard, which is IS 1893. So till now, IS 1946, for under that standard, 3 parts have been released. Part 2 is for design. Part 3 is for the qualification of adhesive anchors, a chemical anchor. Part 4 is for mechanical anchor, testing and assessment. Part 1 is going to be released maybe next month, which is the general provisions of fixing devices. And part 5 is for installation of post-install anchors, which is under preparation. So if I talk about IS 1946 Part 2, these are some highlights or some key points which actually has been covered. The design of connections has been covered for static and seismic loading, considering both the loadings are very, very important for Indian industry, Indian situation. Then, of course, crack concrete, structural and non-structural design provisions, and also it talks about that for any seismic zone 3 and above, if the structure is located in that particular zone, then for connections, for post-install connections also, the seismic design is mandatory. And the anchors which will be used, be it adhesive anchor or mechanical anchor, that should be properly tested and assessed, because as Baz also explained, because for seismic loading it is very important to judge or to assess the behavior of anchor performance under cyclic loading, because the crack widening and opening closing happens during seismic activities. So these are some snapshots from IS 1946 Part 2. You can see the IS 1893 Part 1 has already been cross-referenced here to talk about the seismic design provisions. And also it includes non-structural connections designed for seismic. Even the NBC, the previous one, because of this 1946 released last year, that's why the NBC reference you can see for 2016. But in the note also it is mentioned that for any structures which is or any fastenings which is there for earthquake zones 3 and above, the design needs to be done based on assessment for pulsating tension, crack cycling, and also crack concrete needs to be considered at a crack width of 0.8 millimeter. So if I talk about the relation between global standard or international standard with IS 1893, so this left-hand side has some snapshots from the 2016 version, and this is the snapshot from European standard, which is for post-install anchors EC2 EN 1992 Part 4 and Eurocode 8 EN 1998, which is for the seismic design. So for if I see Eurocode 8 also, the higher performance category, which is C2, is referred that for seismicity level greater than low. The spectral acceleration, if it is greater than 0.1 G, then for importance class building, which is 2, 3, and 5, which you see from the list, it's not like the regular building, which is of minor importance, but the important buildings can be hospitals, can be police quarters, can be any civil protection buildings, fire stations. So all these important buildings, if for that situation, the seismicity level, if it is greater than low, with acceleration value greater than 0.1 G, then the design needs to be done for higher seismic performance category. And if we see IS 1893 Part 1 also, for zone 3 and above, the zone factor is greater than 0.16. So these two codes are also, or standards are also can be correlated, and accordingly IS 1946 also talks about it that for zone 3 and above, where the seismicity level is greater than 0.1 G, the seismic design needs to be done for C2 or higher seismic performance category. So in the draft version of IS 1893, if we see, there is also one clause added, which is architectural elements and utilities, and a dedicated formula has been given to calculate the force depending on the mass of the non-structural element, which is W, and also X, which is the height from the ground to the non-structural element, whether it is it depends on at which floor the non-structural element is connected, depending on that height, and also some factors, which is importance factor, acceleration, amplification factor. All those are mentioned to calculate the force on the non-structural element for seismic as well. And there are different categories mentioned: acceleration sensitive, displacement sensitive, and combined. So depending on the type of non-structural elements, which I mentioned some of the types here, if we consider facade panels, that is displacement sensitive. So if we talk about storage racks and tanks, that is acceleration or vibration sensitive. So based on this, the importance factor and acceleration modification amplification factors will also change, and accordingly force can be calculated as per the upcoming standard. So why post-install anchors under seismic loading? So engineer Barry techniques are already mentioned in detail, but I'd like to little bit highlight on that. That for this is a building structure, and if we talk about any connections or in secondary structure, then it is likely that there can be a plastic zone formation as well. So in general, the crack width is higher than the static loading. For static, we consider for anchor design is 0.3, but for seismic it is 0.8. But in some cases, there can be plastic zone formation, which for where the crack width will be even more higher, because we cannot control seismic cyclic loading, right? It's a natural phenomena. In that situation, anchor performance will drastically drop down. And generally in plastic hinge region, we always recommend to avoid drilling and to avoid anchoring. But if we at all have to do it, then we need to do proper evaluation with all this the cyclic loading, alternating shear, pulsating tension, all these different loading criteria, and the ground acceleration, which will induce the deformation in a structure, and actually it will transfer to connections, the seismic loadings, everything. So for high rate cyclic loading and changing of crack width, which happens in high seismic zone, it is important to design the connections which is post installed. So with this is the message. In message, actually not only the structures but also connections needs to be designed for earthquake. Seismic survival starts at the connection sometimes. I mean, I think majority of the time. So with this, I would like to end my presentation. I think we are almost on the time, and I will try to take some questions, maybe some 2-3 minutes we can spend, if speakers are okay.
Yeah. Yes.
Yeah, so the question which I mentioned, that what to expect, IS 1893 standard will be back, any tentative timeline?
Okay, so for this one, yes, basically in the last meeting of the technical committee, we have devised basically a roadmap of around 8 to 10 months, in which we will be having a critical review of all the clauses, and we will also be doing a couple of stakeholder consultation as well to take the feedback. And of course, we will be trying to come back with the not much changes would be there, but the critical aspects, of course, will be reviewed by the technical committee, and we will come back with our resolution. Yeah. So that is basically the present thought which has been there in the committee.
Yeah. Okay. The next question is also around it, so I think it's already answered. And there are some more questions. So I think we can address it later. Maybe you can write to us, or you can write to Jitendra sir or us. I will give our mail IDs in the chat box, and we will try to accommodate all the questions. Yeah. And I really want to thank both the speakers for spending almost more than 1.5 hours time with Seismic Academy. I hope the participants already got a lot of insightful informations from BIS, and also from not only for structures, from connections perspective also. And we will be conducting more in future. And Jitendra sir, you want to say something?
No, I think it's a very good. I think Mr. Barry wants to say something.
Yes, I have a proposal, because I just promised to Mr. Pulkit in the question box that I would answer his question. Do we still have 1 minute time to answer one question with regards to the relationship between anchors and the base material, then just very quickly, I reckon this is a great question. Let me read it out. So what is the strength relationship between base material, e.g. concrete, and the anchor element? Do we have a concept similar to weak beam, strong column in anchor design? And this is an excellent question, because the answer is actually yes, we do. So we can design anchor connections 3 ways. One, what we call capacity design. This would be some sort of strong anchor and weak attachment or weak fixture approach, where we actually let the fixture fail. We know the forces associated with the yielding of the steel structure, let's say, and we design the anchor connection to these forces. So what will happen here? The fixture will fail first. This is one very safe and very great way of designing anchors. So strong anchors, weak fixture. Second option, and there are 2 options here, the anchors fail, but we can do 2 approaches in this case. So weak anchor, strong attachment. We can do this with elastic design. This is very, very common, where basically we check all the typical failure modes to the anchor group. The only thing we have to pay attention to, especially in seismic design, one of the failure modes associated with anchors is a brittle one, and that's concrete breakout or concrete cone failure. So what we do commonly in seismic design, even if we design to weak anchor, strong attachment, we use overstrength factors against the concrete cone failure. So we increase the forces or we reduce the capacity so we can reduce the potential of the brittle concrete cone breakout happening. That's very, very important in elastic design. That's why I love this question. And then the third option, again, weak anchor, strong attachment. This is probably the most desired way in seismic engineering, if we could design anchors in a ductile way. Now, this is relatively new. This is not common in the world of anchors because it requires special attention and special anchors. But what some of the specifiers do globally, they actually use bonded anchors, but they also use special base plates. And what I mean, they increase the length outside the concrete of the anchor. So they introduce a yielding zone into the anchor. And that sometimes requires a boxy base plate or a special design, but it's doable. And if you can do ductile anchors for a seismic design, yes, for sure, that's the best approach available. It just takes a little bit more time and more detailing, but that's available as well. So long answer short, yes, there are ways, and the same principles we use in structural design for buildings, you can do exactly the same for anchors. Just very important, please remember, brittle failures might happen, so we need to significantly overstrength against concrete cone failure. That's the main message. Thank you very much.
Yeah, thanks, Buzz. I think Dr. Pulkit has already given the answer, received the answer. Yeah, and I think we are already over time. I'd like to thank you everyone once again for joining the session, and also to special thanks to both the speakers. And if any query is there, please write to us. I'll just, after the session, I'll put the mail IDs here, the support mail IDs. Yeah. Okay. Thank you so much. I'll just end the session.
Thank you very much.
Thank you very much, Dr. Agumani. Just like to answer one question. I was looking at the chat box. Mr. Manohar was asking about any revision proposed for IS 16700. So yes, IS 16700 is basically the criteria for the structural safety of tall concrete buildings. So yes, that has also been taken up for the revision by the concerned technical committee at BIS. And in this revision, there is also basically a common consensus of improving the scope of the standard to include the composite tall buildings also. So that is also one other aspect of enhancing the scope of the standard. And once the draft will be ready, it will be available for the public commenting. At that stage, you can just have a review of the draft and you can share your comments basically. Okay. And one more comment from I think Mrs. Seema is there. For irregular buildings, what practical checks do you recommend recommend beyond the software output validation. So as I already mentioned during the presentation also, that in order to address the irregularities, because I know that in most of the cases it is very unavoidable to have the irregularities. So in those aspects, basically the standard provides the guidelines and recommendations how to address the different kinds of horizontal and plan irregularities as well as in the vertical irregularities basically. So all those things are already covered under the table in IS 1893 part 1, so that you can refer basically for the for having the cross checking and recommendations. Okay, thank you.
Yes. Thank you, everyone. Hope to organize some more sessions in future, and we'll keep you updated. Thank you. Thank you, Buzz.
Thank you. All the best.
Thank you.
Bye.
Thank you very much, Mr. Buzz. Thank you. And thank you, Dr. Agomani, for the session. Thank you very much.
Thank you.